Okay, we are going to look at, this is lesson 59, uh, problem number C, and it's a solving problem. So it says solve over the domain, x is between 0 and pi. So x is going to represent an angle, and we're going to limit ourselves to the angles between 0 and pi, or 180 degrees. It's important to note this is a Chapter 8 review question. This is not from Chapter 9, which Lesson 59 is in. So this is just a review. What I notice here is I have it's an equation. I have an equation with a cosine and a sine in it. And I have an x, and then I have an x squared. Now technically it's the sine squared, but there's a squared going on here. So both of those things are problems. I can't combine this into a single x if one is x and one is x squared, and I can't combine it into a single x if one is sine and one is cosine. Now, the trouble with having an x and an x squared is resolved by treating this as a quadratic. So we'll consider this to be a quadratic equation, and we'll show how to solve those in just a minute. The trouble with having the cosine and the sine, that can be resolved by finding an identity for either cosine or sine that relates the one to the other. So I do have a cosine identity that relates cosine to sine, but it's not a very convenient one. It's the half angle, no, I can't even remember what it's called. But it's the one where, the cosine of x is equal to the sine of 90 degrees minus x. And that's really not convenient, because that turns it into a sine of something that's not x. The other identity I have that relates sine squared to cosine squared is the Pythagorean identity. That's the one that says sine squared x plus cosine squared x equals 1. Okay, my Pythagorean identity. I just used this the other day in my Calculus 3 class. It comes up a lot, so it's a good one to memorize. We'll solve it by just subtracting cosine squared x from both sides.
Hi, Daddy.
And we get sine squared x equals 1 minus the cosine squared x. Okay, so we should be familiar with the Pythagorean identities and kind of their iterations, the way that they can be manipulated around. So here I have sine squared x is equal to something with a cosine of x in it. I'm just going to replace that. So I'll rewrite my equation here. 5 cosine x minus 1 equals 2 times, and then in place of sine squared x, 1 minus cosine squared x. We'll distribute the 2, and then we'll have our equation. So 5 cosine x minus 1 equals 2 minus 2 cosine squared of x. Now, to solve this as a quadratic, I need to make this equation, an equation equal to 0. So I'm going to move everything over to the left side, probably. So I can add 2 cosine squared to both sides to get rid of the minus 2 cosine squared. And I can subtract 2 from both sides. So I get positive. So undo that. 2 cosine squared x, move that to the right side by adding it to both sides, plus 5 cosine x, and then subtracting 2 from both sides, I get negative 1 minus 2 is negative 3 equals 0. So I subtracted 2 from both sides, and I added 2 cosine squared of x to both sides. Okay, And that gives me three terms on this left side. I have something cosine squared x plus something cosine x plus something else without an x equals 0. That reminds me of a quadratic. I can make it into a quadratic easily by saying let's make some other variable, maybe n, equal to the cosine of x. So that now I don't have to mess around with cosine of x, I'll just call that n wherever I see it. So this is 2 cosine squared of x would be n squared plus 5 times cosine of x will make that 5n minus 3 equals 0. Alright, now, this is a quadratic. I could just go straight to the quadratic equation, quadratic formula, x equals negative b over plus or minus square root of 2 b squared minus 4ac over all over 2a. But I suspect this one can be factored, so I'm going to take a stab at factoring it before I dive into the quadratic formula. So I've got 2n squared, that's probably 2n times n. Let's see, what would I multiply 2 by to get, let's see, the factors of negative 3, one's going to be positive, one's going to be negative. So when I do my inners and outers and multiplication and then add them together, I'm actually going to be subtracting. So if I think about this, 2 times 3 is 6, and then we'll have a negative 3 times, or 3 is 1 times 3, so minus 1 is 5. So I think it's going to be negative 1, positive 3. Now again, that was kind of informal. I apologize if you don't remember how to do factoring. You can go straight to the quadratic formula. You could do that thing where we take the middle term and split it apart and do the 4-term method. However you do it, just you want to verify to yourself that this is true. 2n times n is 2n squared, and 2n times 3 is 6n, and negative 1 times n is negative 1n, and 6 minus 1 is 5n, which is our middle term there. And then negative 1 times 3 is negative 3, which is our last term. So this is really correct. Those are the factors. So all of that equals, multiply together equals 0, which then that allows us to make two little equations, either 2n minus 1 equals 0, or n plus 3 equals 0. So add 1 to both sides for that first equation, add 1 to both sides, divide by 2, n equals 1/2, or n equals negative 3. Now, this is where we kind of get bogged down in the fact that we've been doing so much quadratic work that we don't want to forget that this is actually a trigonometry problem. So that's where we go back up here and we say, okay, let's remember what is n anyway? N is the cosine of something. So we have two cases here. Either n is 1/2, so the cosine of x equals 1/2, or n equals negative 3, so the cosine of x equals negative 3. Now, the funny thing is that you can't have the cosine be anything that's bigger than 1 or smaller than negative 1. Or that cosine is periodic, it just goes up and down from 1 to down to 0 to negative 1 and back up to 0 and then to 1. So there is no angle that has a cosine, straight up cosine of negative 3. So we'll discard that one even without even trying. I mean, you could type it in your calculator and see what you get, but it's going to say error. So that means that it's the only thing we're looking for is the cosine of 1/2. Now, you can do the calculator. Just type it in your calculator. X equals the inverse cosine. Right? This is asking the calculator to tell you, well, what angle does have a cosine of 1/2? You say the inverse cosine of 1/2, and it'll tell you. Or we can think of it this way. You think about our unit circle, and we remember maybe that the cosine is the adjacent side over the hypotenuse. So if that is 1 and 2, then this angle would be the square root of 3, and that reminds us of our 30, 60, 90 triangle, and this is the 60-degree angle and the 30-degree angle, so that the cosine of 60 degrees is 1/2. Okay. That's probably not the best illustration there, but you get the idea. So x equals 60 degrees because the cosine of 60 degrees is 1/2. And that's the only one that's going to work. And you can try this. We can go back up here to our problem. So kind of thinking up here, just off the cuff, cosine of x, cosine of 60 degrees is 1/2, so that's 5/2 minus 1, which is 5, which is 2/2. So 5/2 minus 2/2 is 3/2. Alright, so the left side is 3/2. On the right side we have the sine of x, 60 degrees. So the sine would be the square root of 3 over 2. Square root of 3 over 2. But of course it's squared, so that would be 3 over 4. But then it's times 2. So 3 times 2 is 6, over 4 reduces to 3 over 2, which is what we had on the other side. So this angle, x equals 60 degrees, does make our sentence true, which is pretty cool. And that's how you would solve it. Sorry for all the babies and children in the background.